Good evening, everyone. We are here for our first presentation of the 2025 GOSA presentation series. We have Korben Cooper here to go over some statistics on Beehive. And with that, we will go straight over to Korben.
Alrighty, thank you very much, Will. Hopefully everyone can hear and see me. If not, I have the chat up on one of my other monitors. So if at any point I go quiet or there's some technical difficulty, please do let me know. But other than that, good evening, everyone. Thank you, Will and Micah, for putting this presentation webinar series together. It's very nice to be here talking about Beehive. And as Will already said, I'm Korben Cooper, and this is going to be a presentation on the observational and statistical analysis of Beehive Geyser's activity during 2024. Now, I do have an absurd amount of info to cover. There's a lot of charts, a lot of pictures, a lot of information. So I'm certainly not going to waste any time. So let's get into it. So really quickly here, I want to mention who I am and why I'm going to be talking about Beehive tonight. So as I already said, I'm Korben Cooper. I've been geyser gazing in significant capacity since 2019. Currently, I am studying petroleum engineering and data science at the Colorado School of Mines. My favorite geyser is Beehive. My second favorite geyser is Beehive's Indicator. And if I had to go for a third and fourth favorite geyser, it would probably be Beehive's South Bubbler and Beehive's West Bubbler. So this definitely puts me in a very unique spot to talk about Beehive. And also, from a data standpoint, I was able to record significant amounts of data, usually at least 4 hours prior to the eruption, on 62 of Beehive's eruptions during 2024. And this puts me in a very unique spot to do a lot of analysis on it using my data science experience to talk really just about everything Beehive during 2024. So, what exactly am I going to be covering tonight? So, the first thing I'm going to look into are intervals and durations. I'm then going to talk briefly about indicator behavior, as well as mentioning the mid cycle indicators that were seen this year. I'm then going to spend quite a lot of time looking into the various progressions that Beehive had this year during the 4 periods that I was able to observe it. I'm then going to talk about the external impacts, so weather, temperature, and time of day that were impacting Beehive during 2024 and that impact Beehive overall during other years as well. And then finally, I'm going to summarize it by talking about the interactions with nearby geysers, namely Dome and Little Squirt. And then finally, I'm going to provide some conclusions and effectively a roadmap on what I at least use to see and talk about Beehive whenever I'm in Yellowstone. So the first thing that I want to look into is intervals. So this chart here on the right shows the interval distribution throughout 2024. So evidently, as you can see, it was very, very reliable in 2024. Beehive had a very good year, with most intervals ranging between 14 and 24 hours. So the x-axis here is in minutes, which can be a little bit confusing, but just note that 1,000 minutes is about 16 and 2/3 hours, and it very much liked erupting around then. So again, most intervals were between 14 and 24 hours. There were some intervals as low as 8 and 9 hours. So a couple of sub 10-hour intervals, as you can see on the left side of that chart. And then also some very long intervals around 2 days that you can see on the right side of the chart. So again, something that I do want to note here really quickly is that I did not try to remove doubles. I felt that would introduce some kind of subjectivity into my data set, and I didn't want to do that. So some of those intervals, especially the ones over 2,000 minutes, are probably double, or even maybe even triple intervals. So keep that in mind. But in general, it was very reliable this year. It did not like to go longer than 24 hours between eruptions, and it really only had one interval over 2 days, which was in January. So again, Beehive this year, very reliable, very short intervals, much better than previous years. So looking away from the distributions and into how the intervals changed over time, these two charts show both a dot plot and a box plot of Beehive intervals by month, and that it does a very good job of showing how Beehive intervals changed over the years. So generally, if you look at the summer months, Beehive was incredibly stable. There was not a lot of variation in Beehive intervals. The average remained relatively consistent across all of the summer months, which is very good, made for a lot of people being able to see a lot of beehives, which is very nice this year. And again, it really liked erupting right around 1,000 minutes, which is 16 and 2/3 hours. And in fact, during the summer, you could pretty much predict that beehive was going to go between 14 and 18 hours, which was incredibly helpful. So looking more into how it changed over time, at the start of the year, beehive was very erratic. When I was there in January, intervals were ranging from 14 hours to one which was more than 2 days. but then it rapidly got better. The intervals rapidly stabilized and improved through February, March, and April before really setting into that stable mode right around May. So again, do note that some of those outliers could be double intervals, like there's that one just before July that you can see is around 2,500 minutes on the chart on the left. I'm pretty confident that's a double interval, but I didn't necessarily want to remove that. But again, you can see that there were a lot of more erratic intervals in the winter, and then it stabilized very quickly and was very reliable for the remainder of the summer, having 14 to 18-hour intervals most of the time. One thing that I do want to highlight really quickly is there are a few outliers as well on the short side. These were clustered around April and the end of the year. These are intervals that were less than 10 hours. And these intervals saw a note just Beehive just erupted. No indicator, just erupted at less than 10 hours. And these were very, very short intervals. And they were clustered around each other. So they were not evenly distributed throughout the year. These super short Beehive intervals, the less than 10-hour ones, were very much clustered between April and May, and then around November and into early December. So intervals were very, very stable this year. Again, lots between 14 and 18 hours, and it was relatively predictable. And that stability stayed very true for durations as well. So Beehive very much was consistent between 4.5 and 5.5 minutes in duration. It preferred just a little bit over 5 minutes. Across 62 beehives, I found myself in pretty much every geyser times entry writing something between 5 minutes 0 seconds and 5 minutes 10 seconds. And that just goes to show that it was incredibly stable in durations and also stronger than previous years, which saw more 4.5 to 5 minute durations. Now, there is a separate mode that you can see on this chart on the right side for no indicator eruptions. Oh, the screen seems to have shifted. Well, it's thinking about it. There we go. So again, on that right side of the chart, you can see that the longer durations were almost a separate mode. These are no indicator eruptions. No indicators had significantly longer durations than eruptions of beehive that had a preceding indicator. And that's very interesting and something that I will talk about more later when exploring the relationship between lead time of beehive's indicator and beehive's duration. So something that I do want to note here is that generally the duration stayed consistent across the year. There wasn't much variation month to month, but winter did see just very slightly longer and very slightly more stable durations. So instead of like a 5 minute beehive in the winter, we were seeing a lot of 5 minute 4 or 5 minute 8 seconds beehives. But that could also just be me being the only observer there and just the way that I record durations. So I didn't really want to say that there is actually a significant change in durations in the winter, and I'm much more comfortable saying that the duration stayed relatively consistent across the entire year between 4.5 and 5.5 minutes, significantly preferring just over 5 minutes. So one of the things that I do really want to hammer in about this year is that no indicators were infrequent during the summer. And by infrequent, I mean there were zero observed no indicators during the summer season, which is frankly a little insane. So I've on this chart here on the right, I've noted no indicator eruptions with purple dots. And as you can see, they were clustered around April and the end of the year, also, which was the time that we saw those super short sub 10-hour beehive intervals. But between those, there were no indicators observed during the summer, which is very, very interesting. One of the things that I've noticed both in actual observation and statistical analysis is that beehive tends to pull more no indicator eruptions around the time that it's undergoing some kind of intense change. So in April, when intervals were dropping rapidly, we saw a lot more no indicator eruptions. In the summer, when beehive was stable, didn't really change much, was having the same progression into an eruption every time, we were not seeing no indicator eruptions. At the end of the year, when the progressions were changing and the bubblers were reactivating, and we started seeing our first south bubbler eruptions, we started seeing the first no indicators return. And this very high density of no indicator eruptions has continued into the new year as well. I just got back from a February trip, and a third of my beehives were no indicator. In December, out of the 16 beehives that I saw, I believe 7 or 8 of them were no indicator eruptions. And that just goes to show that they are a lot more frequent right now because beehives undergoing changes very significantly right now. And so again, no indicators were not observed during the summer, and they were clustered around April and the end of the year when beehive was undergoing intense change. So another thing about no indicators that I wanted to make a quick comment on, even though it's really hard to do actual statistical analysis on this, is that I observed sort of two different types of no indicator eruptions. I had the unique capability of being there during the winter this year when it was having no indicator eruptions. And in both December, this previous February trip, and all the way back to last January, I saw two very distinctive types of no indicator eruptions. The first type, and these names are colloquial, I came up with them on my own. If someone comes up with a better name, I would love to use it because it's kind of wordy and janky to me. But the first type is an indicator lockout where the indicator just refused to erupt. It didn't matter how long you were in the interval, the indicator just did not want to start. So Beehive decided to start instead. This is effectively when Beehive has those big series of splashes for 15, 20, 30 minutes sometimes, and you know that you should be getting Beehive's indicator, but Beehive's indicator doesn't want to start. So eventually those splashes just progress into Beehive actually erupting. So those are sort of more progression based. You know that they're coming. You can tell, hey, the splashing in Beehive is really thick. It's sustained. It's happening a lot. And so that's the first type of no indicator eruption that I observed were indicator lockouts, where the indicator just didn't start and Beehive had a long normal progression until eventually Beehive finally took over and started. And this was about a third of the Beehive eruption, or a third of the no indicator eruptions that I observed, but only a third. The other two-thirds were completely accidental by Beehive on Beehive's part. These accidental Beehive, no indicator Beehives, start from just one random huge splash. You can kind of think of it like Beehive accidentally pressing a red button, and so it has no choice once it presses that red button but to erupt. And so in general, those accidental ones were occurring during more normal intervals or during really short intervals. So those 10-hour intervals were almost all accidental no indicators. The 16, 18 hours were almost all accidental no indicators. And then the intervals that got up by 21, 22, 23, maybe in 24 hours, which was significantly longer than normal, that's when you would get it locking out the indicator and Beehive would have half an hour of progressing splashes into an eruption. So a good note here is that you can sort of, as I talked about earlier, with the no indicators happening around the time of intense change, you can kind of estimate the likelihood of no indicators based on how erratic Beehive is. And I looked at this in previous years, and this statistic held very true during all years that I looked at and all years that I've watched Beehive. When Beehive is not behaving like it should, when it's having erratic intervals, when the weather is doing super weird things, or when it's really cold or temperature changing, or the progression starts shifting. So instead of close to cone erupting, maybe South Bubbler starts erupting. When Beehive is doing something that it wasn't doing the last week or two, generally that's when you start getting more no indicators. So again, no indicators like to happen during times of intense change. So since there were zero no indicators observed in the summer, one of the things I wanted to include this presentation was a video of a no indicator starting. So this no indicator is from December 17th. I was there with Mara. We saw one big splash and then I got my camera out. So hopefully this video comes through, but I just wanted to play this because I know a lot of us have been missing our fix on Beehive having no indicators because it just was not doing that this summer.
Yep. Beehive 1233 no indicator. Beehive 1233 no indicator.
So I just wanted to include that in there briefly, since, as I said, a lot of us haven't seen a no indic. I've been really the only person to see. Myself and Brandon and Mara are really the only people who have seen no indicators in quite a while, which is unfortunate. And hopefully this next summer we'll maybe get some no indicators when you have 5 or 6 geysers sitting at Beehive, which would be awesome. So the last few slides have been talking about no indicator eruptions, but I want to shift focus for a while into actual indicator eruptions and the behaviors that we saw with Beehive's indicator this summer. And perhaps, and I say perhaps, but definitely the most interesting aspect this summer is the changes in the indicator lead time. So before May, before the start of the summer season, and also during the time that we were having at least some no indicator eruptions, indicator lead time was relatively consistent between 5 and 12 minutes. It bounced around a lot. Sometimes you'd get 2 or 3 minutes, sometimes you'd get 10, 12 minutes, but in general, it ranged between 5 and 12 minutes. That was until that big cluster of no indicator eruptions and short beehive intervals around April and into May. Also, when those intervals dropped, is when the indicator started increasing its lead time substantially. So, as you can see on the chart here, that first green bar on the left side shows that Beehive's indicator had relatively stable mean lead time between January and into April. But once those Beehive intervals dropped, once Beehive became very stable, and once it stopped having no indicators, that lead time started increasing dramatically. So the indicator lead time in early May was 5 to 12 minutes. By the time July started, it was 15 to 20 minutes. And it was so reliably having longer indicators that people were no longer running to Beehive when they heard the call for water, but rather calmly gathering their stuff, finishing their lunch at Hams, and then starting to waddle over to Beehive and still making it with 5 to 10 minutes of extra spare time, which is a little bit insane. So again, that second green bar, increasing indicator lead times between May, June, and July. On July 26th, I believe it was, there was a 35-minute indicator lead time. This was one of the longest indicator lead times observed in a very long time and was a very noteworthy event that had a lot of people very concerned about the possibility of true, genuine false indicators. Now, luckily, Beehive did erupt at the end of that 35-minute indicator. Somehow, I hear it was a very short duration eruption, very loud. I hear, but thankfully, it did at least erupt. But an interesting note when it comes to an analysis of indicator lead times, right after that indicator, the indicator had that 35-minute lead time, it stabilized. It stopped increasing its lead time. It's almost as if that 35-minute indicator made Beehive realize that it can't keep letting the indicator keep getting longer and longer and longer. And then the average mean indicator lead time stabilized right around 15 to 20 minutes, which again, very long. And again, I mean, if you were at Hams and you heard the water and indicator call in August, you could probably go in, buy a burger, eat your burger, walk out, walk to the overlook, and watch Beehive erupt, which is pretty insane and definitely a sharp difference from the start of the year. So again, after that 35-minute indicator on July 26th, that third green bar in the middle, shows that the indicator lead times were very, very stable across the end of the summer, right around 15 to 20 minutes. Now, into October, when I got there, the indicator was still having those 15 to 20-minute lead times. But by the time I left, less than a week later, those indicator lead times were already starting to drop again. So, also at the same time that the South Bubbler started having very light visible water in October, the indicator lead time started dropping very, very rapidly. So, it decreased between October and November from that 15 to 20 minutes back into the much more normal 10 to 12 minutes, and then back down into the more short end of 5 to 12 minutes. This drop, at the end of this drop, as you can see, there no indicator eruption started again. So starting in November, we have these big clusters of no indicators. Water comes back up in the bubblers. Close to cone stops being important entirely. And then heading into the new year, the indicator lead times are remaining relatively stable around 5 to 12 minutes. So to summarize that, because that's a lot of information, the indicator lead times had a huge hump in the summer, increasing very dramatically in July, between July and October, having 15 to 20-minute indicators as well as one 35-minute indicator lead time. And there were no indicators observed during the time that the indicator was long, but we're already back with two more no indicators and also shorter indicator lead times. But this significant hump, this increase, then flattening, then decrease of indicator lead times in the summer is very, very interesting and not something that I saw as significantly during previous years. Interestingly, as well, these longer indicators correlated with the presence of mid cycle indicators. So, mid cycle indicators are relatively weak indicators. They lasted between 1 and 3 minutes and happened about somewhere between 6 and 8.5 hours after Beehive ended. So these started in July around the time that the indicator was really, really increasing its lead time between that 15 and 20-minute mark. They rapidly increased in frequency immediately following that 35-minute indicator, and then they continued into the end of the summer season, at which point they probably stopped around the same time that we saw our first no indicators. So although there's only 20 or so that were observed and listed in geyser times, it is worth noting that Beehive isn't commonly observed directly between 6 and 8 hours because I mean I sit at Beehive whenever I can, and not even I would want to be there 6 to 8 hours for it to watch it not be splashing and have no chance of erupting. And me not wanting to be at Beehive says something. So there's really no reason for anyone to be at Beehive at that time unless you're specifically watching for mid cycles, which no one was. And this means that we probably missed a ton of mid cycle indicators. I don't want to say anything with certainty, but it's my opinion that towards the end of the summer, especially September and into October, most beehives were probably having mid-cycle indicators, which is very, very interesting. And mid-cycle indicators haven't really been observed in this frequency since at, well since the bad times when we were getting false indicators. Now we were very concerned about those false indicators for a while, but thankfully there were zero true false indicators observed this summer. The only time that the indicator was erupting without a following beehive was when it was having these mid cycles, which were again weak, pathetic, short in duration, and evidently happening at a time that Beehive could not possibly erupt. Interestingly, and I say interestingly, but more in a not interesting sense, mid-cycle indicators were not correlated with any other Beehive factor. The duration, the interval, the presence of big splashing, or the progression into a beehive didn't seem to be impacted based on any mid-cycle indicator observations. So these, at least for beehives, seemed relatively irrelevant and were probably more just a product of the indicator being super strong because it was having those very long indicator lead times during the end of the summer. So one of my favorite statistical analyses that I performed on Beehive for this year specifically, was analyzing the relationship between duration and indicator lead times. So this chart on the right shows a box plot of Beehive's duration bucketed by the different indicator lead times in minutes. And as you can see, there is a very, very clear trend that the longer the indicator erupts, the shorter a duration Beehive you are going to receive. So on the left, you see those 0 minute indicator lead times, those no indicator eruptions have substantially longer durations, almost as if they're an entirely separate mode of beehive eruption. And then after that, every minute you get of indicator, beehive gets gradually and gradually shorter. So durations this year were relatively strong, but still, if you had a 5 to 12-minute indicator lead time, you were probably going to get a beehive just over 5 minutes. If you had one of those 20-minute indicator lead times, it was going to be 20 seconds shorter. And this trend held true across other years that I analyzed as well. So it's unlikely a product of just the indicate of Beehive just having shorter durations during the same time that the indicator was long. This is more likely to be an actual correlation and potentially an impact. Now, unfortunately, statistics don't lend much to causation as much as correlation, but at least in my personal opinion, it's relatively intuitive that the longer an indicator, the more water the indicator is going to use, and probably the shorter beehive you are going to get, and or some resemblance of a connection between those. So again, durations are negatively impacted by increasing lead times from the indicator. If you have a long indicator lead time, you're unfortunately not going to have as much beehive. Now, this is good and bad, of course, because obviously the long indicators, as Ben said, are very, very nice for being able to see beehive. Because if you can be sitting at lower hams, hear an indicator call, and then gradually and calmly walk over to beehive, even if it's 10 seconds shorter, at least you got to the hill for that beehive. So taking a step away from those big annoying charts into big annoying tables instead, I want to talk a lot tonight about the various progressions that Beehive has. And by progression, I mean what exactly is Beehive doing building into an eruption. So I was able to very luckily observe Beehive across 4 time periods. I was there for a week in January, I was there for an entire month in June, I was there for a bit over a week in October, and I was there for a bit over 2 weeks at the end of December. And I made a very key point of showing up to Beehive earlier than I needed to, just to watch it and track what it was doing prior to an eruption. So in general, I tracked behavior from a couple of features, and I'll show a map of these on the next slide. But they were the close to cone indicator, the west bubbler, the south bubbler frying pan, and then I also noted strong beehive splashing and strong indicator steam. I did my best to combine all of my observations into this table, which again, I'll post at the end of this presentation as well for anyone wanting to go look back at it in more detail. But in general, those were the features that were most important. So one of the most important tools in observing Beehive is its progression into an eruption. Beehive generally follows a very clear and defined checklist for any given observational period, where certain vents or certain bubblers will exhibit very specific and easy to see behavior in a very clear, orderly step by step procedure that will build into an eruption. This usually results in Beehive having sort of an indicator, a so called, you can kind of call it a dinner bell, where Beehive will just ring the bell and say, hey, this feature is going to do this 2 hours before an eruption. And once you can key into what that dinner bell is, you're going to have a lot better chance of seeing every single Beehive. Because that thing, that startup sequence, that checklist, tends to only change very gradually over time and tends to be very reliable for weeks at a time, which is very, very helpful. So for January, and for example, the sort of dinner bell was when South Bubbler was starting without West Bubbler. In June and October, it was when the close to cone indicator was strong and consistent. And in December, as well as my very recent February trip, it was when the South Bubbler frying pan was coming on. So, one of the most important things to note when you are watching Beehive is what's its so called dinner bell? What is it doing an hour or 2 hours before an eruption? What bubbler or what feature is exhibiting what type of behavior at what time relative to a Beehive eruption? And when you compile this data or even just sit there for a couple eruptions, you're going to pick up on the checklist that Beehive is following. And once you understand that checklist, you can pretty much know exactly what Beehive is going to do building up to an eruption. And so you can better gauge when you need to be sitting there. So again, this is just a quick map of those features that I was talking about. Obviously, you have Beehive in the center, big, beautiful cone. Love that thing to death. Just in front of it, you have the close to cone indicator, which erupts from that small crack. Usually, the close to cone indicator is small bubbling, no more than 3 to 6 inches. It has had significant eruptions, sometimes as tall as the cone in the past, but it unfortunately does not do those anymore. Obviously, Beehive's indicator in the front, and then the smaller features, but also sometimes the most important features, are the west bubbler, which is on the back right of Beehive's cone. In this image, you can actually see it very lightly overflowing. It is that big pool sort of on that ridge just to the right of Beehive's cone. And sometimes this year that would fill before an eruption. Sometimes it was that dinner bell. So by knowing what the dinner bell is, you can look at West Bubbler, and if West Bubbler overflowing is that dinner bell, and West Bubbler is not overflowing yet, you know you can leave for an hour or two and come back. On the left side of the cone, the most important features are the South Bubbler and the South Bubbler's frying pan. The South Bubbler in this picture is that small pool of water. It's very hard to see. It's a lot easier when you're in person because it tends to bob up and down like a little fishing bobber. But right behind it is the frying pan, which is that it's a steam vent effectively. It'll huff steam when it comes on, and it's located just behind the South Bubbler. But that map does a pretty good job of showing the main features that I was looking out for. And again, the main point that I really want to hammer in during this presentation is if you're trying to see Beehive, watch the bubblers, pick up on what checklist Beehive is following, and you'll very, very quickly realize that it has some kind of dinner bell that will tell you exactly where Beehive is in its progression and whether or not it's actually ready to erupt yet. To give a few examples of this, I do want to take a few minutes and look into each of the progression cycles and startup checklists that I saw during my 4 observational periods in 2024. So looking at January, about 12 hours after Beehive erupted, the close to cone indicator would come on. That was not very important. It was sometimes Beehive was erupting at 16 hours, sometimes Beehive was erupting at 2 days. So the fact that it was coming, that close to cone was starting exactly 12 hours after every Beehive was not very helpful, but was the very, very first step in its progression. So eventually, over time, the south bubblers and west bubblers would start to fill with water until eventually south bubblers started having a series of eruptions. Now, in January, a series of south bubbler eruptions would always start with a west bubbler eruption, shortly followed by a south bubbler eruption. That south bubbler eruption would shut off west bubbler. West bubbler would drain, and then south bubbler would stop. West bubbler and south bubbler would refill until west starts, south starts, west shuts off, south shuts off, and that cycle just repeated and repeated and repeated for many, many south bubblers. That was sort of the first sign that Beehive could potentially be getting ready to erupt. But again, that was starting sometimes 12 hours, sometimes a couple hours before the eruption, sometimes 12, 14 hours before the eruption. So not very helpful. What I did pick up on after 2 eruptions was that the south bubbler would eventually start erupting without the west bubbler. South bubbler would just start. It no longer needed the west bubbler to erupt. Also, the south bubbler intervals would drop from 15 minutes all the way down to 10 minutes. This was in January. That was the dinner bell. When south bubbler was erupting without west bubbler, that was the dinner bell. If I saw south bubbler erupting without west bubbler, I would be able to confidently say that Beehive is going to be soon, and I would use that observation to know when to sit there versus not sit there. Or at least you could. I personally, whenever I'm at Walk by Beehive, I have to sit there for at least a few hours. It's pretty much coded into my DNA at this point. But you could, if you were trying to see Beehive and also see other geysers, which I do highly recommend other geysers as well, just not as much as Beehive. Once you pick up on that dinner bell, if you walk by Beehive and that dinner bell is not ringing, generally you can come back in an hour or two and see if that dinner bell has started yet. So in June, and this June observation will also continue pretty well into October, the progression had changed entirely. South Bubbler, completely dry, completely empty, would not steam, would not fill up, would not erupt before Beehive. Instead, it was the progression of close to cone that was ringing the dinner bell. So close to cone was still turning on 12 hours after Beehive, but sometime between 15 and 120 minutes before Beehive, the close to cone indicator would rapidly get stronger, going from sort of weak blipping to strong and consistent sputtering. Now, strong and consistent sputtering, I described that as 3 to 6 inch sputtering that had to be consistently audible from the boardwalk, even with people walking around you. And that in June was the dinner bell. Once that close to cone indicator became strong and consistent, you knew that Beehive was coming up. You knew that it was soon. You knew that you needed to sit there. If you got to Beehive and the close to cone indicator was still weak, you could probably leave, go watch a few turbines at Grand, and then come back and see if Beehive was ringing that dinner bell yet. This stayed very true into October. Again, these progression cycles, they tend not to change instantaneously. They tend to be more broadly shifting over a period of a couple weeks or months. So in October, it was still very similar to June. Close to cone was still coming on strong. Close to cone was still the key element, the dinner bell that Beehive was ringing to tell you that it was coming up. But instead of 15 to 150 minutes, it was now 45 to 200 minutes. So by understanding not only what the dinner bell is, but when the dinner bell is ringing relative to Beehive's eruption, you can get a better gauge on how close you actually are to Beehive erupting. So in June, if the close to cone indicator was coming on strong, Beehive could be in a couple of minutes. In October, you could probably dilly-dally and wander your way up from down base and still get to Beehive in time to watch water in the indicator. So again, very, very important to watch out for what the dinner bell is, as well as when that dinner bell is starting to ring relative to Beehive's eruption. So in December, close to cone had become relatively irrelevant, which was unfortunate because I love close to cone. It makes a very nice noise when it's strong and consistent. But still, Beehive was ringing a very clear dinner bell. It took me 2 eruptions to pick up on the fact that the south bubbler frying pan was turning on almost exactly 2 hours before either the indicator or Beehive was erupting. So in that picture in the bottom right, you can see that frying pan steaming. When it turns on, it sort of huffs steam continuously, a little bit like kind of like what Old Faithful does, but on a very, very much smaller scale, where it's just continuously huffing and putting out big little billowing clouds of steam. And that was the dinner bell in December. That was what was telling me to sit for Beehive. If I got to Beehive at 10 p.m. and the South Bubbler frying pan was not on, I knew I was safe to go back to my cabin, take a shower, take a quick nap, and then come out in an hour and a half and see if that frying pan had turned on yet. Also, during this time, once the frying pan was on, the south and west bubblers would fill with water and occasionally erupt, but this was only happening after the frying pan had turned on. And so the dinner bell was still very much the frying pan, but the other bubblers were still exhibiting interesting behavior leading up to the eruption. So again, Beehive has a sort of startup checklist. It's going to do something, and then it's going to do a next thing, and then another thing, and then another thing, and then erupt. What those things are changes gradually over time, but generally, once you pick up on what the key components are in that startup checklist, it is almost like Beehive is ringing a literal dinner bell telling you that it is time to sit there and that it is ready to erupt. And again, this slide just summarizes all of that because it is probably, in my opinion, the most important factor when trying to see Beehive is what the startup sequence is. And so the main insight to be gained is that Beehive follows a checklist. If you pick up on that checklist, you can use that checklist to track where Beehive is. Even if Beehive intervals are ranging from 16 hours to more than 2 days, the checklist tends to be reliable, or at least that is what I saw in January, June, October, and December of this year, as well as my previous February trip just now, and all of my previous Yellowstone trips. Even if Beehive is erratic, that progression checklist, that startup sequence, that dinner bell is still ringing at a reliable time. So if you're going to get a 16-hour interval and the South Bubbler frying pan is coming on 2 hours before, it's going to turn on at 14 hours. If you're going to get a 24-hour interval, it's going to turn on at 22 hours. So it's very, very useful for tracking where Beehive actually is relative to an eruption, because now you no longer need to just use intervals. You can use the behavior from the bubblers to understand if Beehive is actually ready to erupt yet or not. So getting away from Beehive's direct behavior and into more of what external considerations you might need to consider when trying to sit Beehive. One of the most notable ones for 2024 and previous years is time of day. It's a geyser on Geyser Hill, so I figured during my analysis I should probably look into whether or not it was impacted by time of day, and it very, very much is. So again, lots of features on Geyser Hill are diurnal. Beehive's no different. In 2022, for example, it was pretty much Beehive was banned from erupting overnight. If Beehive had not erupted by 5 p.m., no matter how ready it was, it would most likely wait until the following morning. That time of day impact was still observed this year, but on a significantly lesser magnitude. So as the density charts on the right show, the bottom one being relative to time of eruption relative to sunrise, and the top one being time of eruption relative to sunset, Beehive tends to prefer mid-morning. It likes to wake up after sunrise. So a lot of times I saw Beehive would be ready to erupt at 6 a.m., but it would just hold out as long as it possibly could until 9 or 10 a.m., 3 to 5 hours after sunrise, to erupt. It also very much does not like erupting in the hour after sunset. The 2200 hour this year during the summer was effectively forbidden. I believe, if I'm remembering my statistics right, between June and October, it had one eruption during the 2200 hour across multiple hundred of Beehive eruptions. That's very, very significant. In fact, you would often see once the sun went down, no matter how ready Beehive was to erupt, it would just die. It would stop splashing, it would go quiet, it would stop grumbling. And that both observationally and statistically is significant that Beehive has a very clear time of day preference. It does not like erupting right after sunset. It does like erupting a few hours after sunrise. Now, a good note here is that when Beehive does die, either from time of day or temperature or rain, which are what I'm going to be talking about next, it tends to take somewhere between 3 and 5 hours for it to kick back in. So it's not like if Beehive gets impacted by time of day, it's going to be dead for an incredibly long time. It's just going to calm down and delay it for a couple hours. It's almost like it tried to have its startup sequence, then something told it no, and so it has to go all the way back to the beginning and progress again, and that can take multiple hours. So again, this is just a more of a distribution chart showing the number of Beehive eruptions in 2024 during each individual hour. Now this is across the entire year and also in UTC time. I'm sorry I did not put the MDT time or MST time in there, but for UTC is around 2200 in Mountain Time. So keep that in mind, that 4 o'clock hour in UTC, which is the time that Beehive just really preferred not to erupt, is that 10 p.m. hour that I just talked about. So in general, although there is of course some nighttime observational bias because less people are going to be sitting at Beehive and watching Beehive during the night, Beehive did show strong preference for erupting during daylight hours, particularly in the early mornings after sunrise, and then showed a strong distaste for erupting after sunset. And understanding in general across multiple years that Beehive is impacted by time of day and having that consideration in the back of your mind when you're observing it can help you pick up on subtle differences. It's like this summer, once I picked up on the fact that Beehive wasn't erupting at the 2200 hour, even though I, of course, was still sitting there at the 2200 hour, I was not actually expecting it to erupt. So another thing that impacts Beehive very significantly is precipitation. So in previous years, and this year is no different, Beehive has shown a significant distaste for wet weather. It does not like rain, it does not like snow, it certainly does not like heavy thunderstorms. And these precipitation events in general, especially when they happen close to the time of a beehive eruption, will lengthen your interval. Beehive does not like the rain. If it is a hot, sunny day and you are sitting at Beehive and it is ready to erupt at 4 p.m., and then a huge thunderstorm comes through, it might not erupt until 1 or 2 in the morning. In fact, this summer in June, I was sitting there at Beehive. It was probably within 15 minutes of erupting. It had completed all of the necessary steps in its startup sequence. Close to cone was strong and consistent. We were getting huge splashes. I was expecting water in the indicator any minute. And then a huge thunderstorm rolled through, big enough that a couple of the geysers who were on the boardwalk had their hair stand up from electricity. But once that rain started, a huge wave of water rushed down the hill right into the indicator, and almost like it snapped its fingers, Beehive just went dead silent. It ended up erupting 7 hours later at 1 in the morning, and I unfortunately was not there for that. But yes, in general, precipitation is very, very bad for Beehive and will cause active regression. Beehive, if it rains or if it snows heavily, and Beehive decides it wants to be impacted by that, it is going to actively regress. It is going to shut down the bubblers. It is going to have to restart that startup sequence. It will effectively say, hey, I know I'm ringing this dinner bell, but also someone just told me that it's going to rain. And so I'm going to wait until 5 or 6 hours after the rainstorm to start ringing the dinner bell again. So, in addition to time of day and precipitation, Beehive did show some impact from temperature. So, in general, it did not like cold weather, but it did very much like warm weather. So, if it was a colder day, Beehive would probably take a bit of extra time. It would probably have a slightly longer interval. But if it was a sunny and warm day, it might go shorter. Now, an important thing to note here is I'm not necessarily talking about summer versus winter, although Beehive does tend to be a bit more erratic in the winter than the summer. I'm talking more about temperature relative to the days immediately around your visit. So if you're there in June and you had 4 70-degree days in a row, and then you suddenly get a 50-degree day, Beehive is most likely going to wait a few extra hours on that 50-degree day just because it is impacted, or at least something is impacted by that cold temperature that causes Beehive not to erupt as soon as it should have. Same thing in the winter. If you've had a couple 20-degree days and then suddenly you get a 0-degree day, it's probably going to wait a couple hours. So in general, cold weather does not impact Beehive positively, which is a bit unfortunate. But it does like warm weather. So a good, hot, sunny afternoon is very, very good for Beehive. Beehive really actually likes erupting with very short intervals. If you've had a hot day, a sunny day, a low wind day, and it really likes to go on those hot, sunny afternoons. So keep in mind that if you've just had a suddenly cold day, you might expect that Beehive is going to wait a little longer. But if you've had a really hot, sunny day, you can kind of expect that Beehive is going to go sooner. And I just had this impact me on my previous February trip. I was ready to leave on the snow coach in the afternoon. It was 1 p.m. It was a super hot day, and probably because it was a super hot, sunny day, it was 50 degrees in February and March, which is a bit absurd for Yellowstone this time of year. Uh, Beehive pulled a super short interval, and I was able to make a very, very fast run from the snow lodge and see it from Geyser Hill. So again, keep both temperature and precipitation in the back of your mind because they can have an impact in addition to that time of day. So a very quick summary slide here on a couple of the things that Beehive likes and dislikes. Precipitation does not like precipitation. If it's having a really rainy day, Beehive's probably going to go a little longer. It does not like cold weather. If it's a really cold day, Beehive's probably going to wait a little longer. It does not like the sun going down. It tries to go to bed, and it does, and it will actively regress a lot of times right after sunset. And I also saw this just in my past February trip. But it does like warm weather. So if it's a warm, sunny afternoon, you can expect that Beehive might go a little shorter. A good thing to watch out for with all four of these is active regression or progression. So if it rains and the progression, but Beehive keeps progressing, it keeps getting bigger and bigger splashes, that might be one of those odd intervals where Beehive just isn't impacted by precipitation, which I saw, I think, 3 or 4 of this year out of 62, where it didn't care as much and would just sort of ignore it until, usually because the precipitation was light enough. But again, watch for that active regression. If it rains or it gets cold or the sun goes down and Beehive actively regresses, it stops splashing, it gets quieter. Sometimes the bubblers will even drain or close to cone will stop erupting. You generally can assume that Beehive's going to go a little longer. It's going to need to recover from that regression, and generally it's safe to leave it for a couple hours. So I love Beehive. I love watching Beehive erupt. And unfortunately, a lot of the statistics that I run are on things that make Beehive very unhappy. So running math on cold weather and precipitation and sitting there on cold and rainy days when Beehive just gets really sad because it's cold and rainy, I'm not a fan of that because I like seeing Beehive erupt. So I wanted to do a lot of looking into what makes Beehive happy. And one of the biggest thing that makes Beehive happy, especially during 2024, are dome series. So Beehive respond very, very positively to dome series. In fact, in 2024, dome would generally shorten Beehive's intervals by somewhere between 2 and 4 hours, which is significant. In December, when I was there, Beehive was pulling 16 to 18-hour intervals. I saw the start of a dome series, and the next 3 intervals were all 14 hours. So in general, Beehive respond very, very positively to dome. Now, an interesting nuance with the way that dome impacts Beehive is it doesn't necessarily impact the same beehives every time. So sometimes it will impact the first and second beehive after the dome series starts, sometimes the second and third, sometimes the third and fourth. You don't exactly know which beehive is going to be impacted by dome until you see that short interval show up. But pretty much always in 2024 and in a lot of previous years, Beehive was very positively impacted by dome series and dome eruptions. A similar impact was observed with Little Squirt Geyser. Although Dome was shortening it by 2 to 4 hours, Little Squirt was only shortening Beehive by somewhere between 15 and 112 minutes. And that was ran for anytime that Little Squirt was erupting within the previous Beehive interval, which I just sort of generically called 18 hours to make crunching numbers a little bit easier. But in general, Beehive does like erupting a little bit on shorter intervals around the time that Little Squirt's erupting. So if you're walking around the hill trying to see a beehive, keep a close eye on Dome, keep a close eye on Little Squirt, and if either of them are erupting, kind of keep it in the back of your mind that maybe you should get to Beehive a little earlier in case it does pull one of those short intervals. So this presentation has gone over a absurd amount of Beehive information. I've spent multiple months now compiling all of this data, and it's a lot to go through. So I wanted to summarize everything by sort of giving a roadmap on all of the considerations that I make and that people, in my opinion, should generally make when trying to see Beehive. So one of the first things to consider, and probably the most important thing to consider, is that startup sequence. So generally, Beehive likes to ring a dinner bell. If you get to Beehive and you track what it's doing, yeah. If you get to Beehive, there we go. But if you get to Beehive and you track what's going on, it's probably you're probably going to figure out what that dinner bell is. And once you figure out what that dinner bell is, you're going to have a very, very good chance of walking by it, seeing that that dinner bell is on, and then knowing that you need to sit for Beehive. So keeping track of that startup sequence, paying attention to notes and geyser times on what Beehive did prior to the eruption is very, very helpful. Also, if you're not necessarily watching the startup sequence, a good thing to keep an eye on are just the recent intervals. Beehive doesn't Beehive can be very erratic, but oftentimes intervals fall relatively close to each other for weeks at a time. So keeping an eye on what Beehive has been pulling interval wise for the recent few weeks can sort of give you a general idea on when you want to be at Beehive. So I tend to look at those previous intervals, determine the earliest possible time that I want to get to Beehive, and then see if that startup sequence has started yet. If you get to Beehive and it's on that early end of the interval window and the startup sequence has not started yet, that dinner bell is not ringing, generally you can go do something else for an hour or two and then come back and see if that startup sequence has begun and see if that dinner bell is ringing. You can also keep a close eye on stability. So sometimes Beehive has very, very stable periods of time. Like right now, this week, it's pulling a lot of 13 to 15-hour eruptions. So generally, it's safe to assume that you should be sitting at Beehive during those times because it's most likely to erupt. And it's most likely not going to go over 24 hours. So keeping stability, intervals, and the dinner bell in mind are all very, very helpful for determining when you should be sitting at Beehive. Now, if you're not planning to be sitting at Beehive for hours on end, a good thing to keep an eye on is the indicator behavior. So if the indicator is having long eruptions and having 12, 15, 20-minute lead times, you can probably be more comfortable going a bit farther away from Beehive because you know that you're going to have time getting there. If you're having no indicator eruptions frequently at Beehive, you might not want to go out of sight of Beehive in case it does pull that no indicator eruption. Again, if you're not sitting at Beehive, keep an eye on what the indicator's been doing and determining what the expected lead time is so that you know where to be in case that indicator does start. And then also do keep an eye on season because Beehive does tend to have sort of seasonal modes. It'll get locked into something for the summer, it'll get locked into something for the winter. This summer, it was locked into very stable. Last winter, it was locked into very unstable. And this winter, so far, it seems to be somewhere in the middle. But keep an eye on startup sequence, recent intervals, how stable Beehive has been, what the indicator's been doing, and what sort of seasonal mode it's in. And generally, you can get a good idea on what Beehive's going to be doing and when you should be sitting there. Also, in addition to keeping in mind what Beehive is doing, it's important to pay attention to what is going on around Beehive. So this includes time of day, precipitation, temperature, dome, and little squirt, especially for 2024. Now, in general, this presentation is all about the activity in 2024, but a lot of these factors are very applicable to other years. So keeping an eye on Beehive's preference for time of day across a given year, if it really is hating the night for a specific year, generally you can leave after sunset. This year, if it's hating 10 p.m., you might not need to show up until midnight or 1 a.m. Precipitation wise, it tends to have longer intervals and active regression during big precipitation events. So you can generally, if there's a big snowstorm coming in or a huge thunderstorm, feel a little more confident waiting a couple hours to start your sit. Same thing with very cold nights. It really does not like erupting on short intervals when it's really cold out, abnormally cold out, I should say. But if it's really warm, you might want to get to Beehive a little earlier. Also, keep an eye on what Dome and Little Squirt are doing, because as I've mentioned, Dome and Little Squirt have a very positive impact on Beehive. So if you see on Geyser Times that Dome is in series, you might want to show up to Beehive a little bit earlier. So in general, the way I approach looking at Beehive is the first thing is I'm going to try and figure out the startup sequence. Every time I get to Yellowstone, my first couple Beehive sits are spent solely trying to watch and figure out what the startup sequence is. Because once I figure out that startup sequence, once I know what the dinner bell is, I can use whether or not that dinner bell is ringing to determine whether or not I should be sitting at Beehive or whether or not I need to be sitting at Beehive. Honing in on that startup sequence, the checklist that it follows, makes it very, very easy to gauge how happy Beehive is. Because as we all know, sometimes that splashing can be very, very deceptive. I've seen really big splashes at 11 hours that have made me sit there for 12, 13, 14 hours until it erupts at 27 hours, which is very annoying. So paying attention to that startup sequence, understanding what it's doing and when relative to an eruption is very helpful. Also, keep in mind, just in general, what Beehive has been doing recently. Has it been caring much about the dark? Has it had significant or insignificant precipitation impacts? Is it liking Dome? What in general is Beehive doing? Is it being stable? Is it having a lot of 16 to 18-hour intervals? If yes, then maybe you want to be there from 16 to 18 hours. If it's being very erratic, maybe you want to pay more attention to the startup sequence. But in general, once you figure out the startup sequence, which in my opinion is the most important part of observing Beehive, you can generally just sort of keep the considerations of what Beehive's doing, what its recent intervals are, and what the external impacts have been recently in mind to determine when you should start your sit. So, especially this previous February trip, when I was not wanting to get to Beehive and spend the entire night sitting at Beehive because it's cold and in the winter, the method that I was using is I would look at the recent stability of Beehive, look at its recent intervals, take into account what Dome was doing, what Little Squirt was doing, what the weather was doing, and then I would determine the earliest reasonable time that I should start sitting at Beehive. I would go to Beehive at that time, and using what I had learned about the startup sequence from a couple previous eruptions, I would gauge whether or not Beehive was ready to start yet. If Beehive was ready to erupt, if that dinner bell was ringing, At that point, I would sit down and I would wait those couple of hours until Beehive erupts. If not, I would leave and come back an hour or two later and then reevaluate and determine based on that dinner bell. So you can almost use what Beehive has been doing recently as a time to get there, and then use the startup sequence as your determination of whether or not you should wait. So with that, I have gone through a ton of information tonight. I am sure there are quite a handful of questions out there or clarifications that I need to make. So are there any questions? And also, before I get to that, I should note that Micah Kipple is going to be presenting on March 11th, so 1 week from today, at the same time, same place, and I highly recommend everyone tune in because that's going to be a great presentation. So with that, are there any questions? And Will, you might have to relay the questions. Beehive, as far as I could tell in my analysis, it did not. Beehive, the no indicator durations were relatively consistent regardless of whether or not the indicator was erupting during Beehive or not. But also, it's worth noting that I only saw that there were only a handful of actual good data points for that this year. So whether or not there is actually a relationship there would require a little bit more analysis, and we would need a little bit more data.
Did it always erupt every time?
Assuming you're talking about the
Same
indicator during,
continuation.
yeah, during no indicators, no. I observed multiple beehives this year where beehive would start and you would not see an indicator at all. Other times you would have beehive start and you would have 20 or 30 seconds of the indicator. Sometimes beehive would start and you would immediately get water in the indicator right as beehive is starting, and then the indicator would erupt for the majority of beehive eruption. Now, in general, during an eruption of beehive that does have a preceding indicator, I think it's worth noting that the indicator does shut off before the end of beehive. Scrolling up to, I finally pulled up the YouTube on my other screen so I can take the questions from
There.
here. But from Graham, any height variations based on any of those factors? I do not know. That is a question that I will refer to Ben, who seems to have answered it with maybe indicator lead time. And that is also something that I've sort of anecdotally observed is no indicator eruptions. Beehive might be a little shorter, a little weaker on the height side. Also from Graham, once close to cone was consistent, did it back off to weak again? Same for BSB South Bubbler, and then did it back off sometimes? Yes and no. So in general, once it did back off, but not significantly, is what I should say. Sometimes close to cone would come on very strong and consistent, and then it would have periods where it would die down for 3 or 4 minutes. But generally, the time between the dinner bell and Beehive's eruption was from the first start of that dinner bell, the first time Beehive rang that dinner bell, to the time of the eruption. That was very consistent. So even if the close to cone indicator backed off, generally that wouldn't impact how long you had until Beehive, just as long as it had been reliably strong and consistent for a little while. Now that there is a good exception to that, which is when Beehive gets actively regressed by something like the sunset or rain. At that point, once those bubblers back off, sort of if they have a reason to back off, then you can usually use that as a sign that Beehive is going to be delayed. But otherwise, once that dinner bell rings for the first time, Beehive's eruption is a consistent amount of time away, regardless of whether or not it backs off. And a good example of that is just this trip that I got back from on Sunday. I saw a Beehive interval where South Bubbler's frying pan turned on. It was on for half an hour and then it turned off for 15 minutes before restarting. And Beehive was still 2 hours after the first time that the frying pan came on. And if that does not answer, that's a lot of words, but if that doesn't answer your question, Graham, let me know. Also from Graham, how many eruptions did I need to figure out the dinner bell each visit? Usually two. So I would pretty much always pick up on it the very first time that I saw Beehive, and then the second eruption was sort of confirming that I saw what I saw. So in general, if you sit there for at least 2 or 3 eruptions and you see the same thing happening, that's probably the dinner bell. So it does not take very much to determine what that dinner bell is. So Ben, I'm going to ask you to clarify your question. What do you mean by was there ever a point of no return other than indicator starting? Are you referring to when like a point where Beehive would not be able to actively regress? I'll give him a second to answer to clarify that question. Yeah, okay. Yeah. So Ben's question, to reiterate, is was there ever a point of no return where Beehive had progressed far enough that no matter what happened to it, it would erupt? And the answer is yes. And it was before the indicator would start. Generally, once you get a significant increase in progression beyond what the dinner bell is, Beehive was pretty much locked into an eruption. So, for example, in December, when it was the frying pan that was ringing the dinner bell, if you got significant water coming up in the south and west bubblers, it no longer mattered what was happening with rain or snow or temperature, but it would just erupt. So once you get significant increase beyond your dinner bell, generally Beehive is locked into an eruption and nothing will impact it. And that next thing beyond the dinner bell sometimes is the indicator, which is what we saw in June and October this year, where the only real progression sign was close to cone coming on strong. But during this winter, when you would get the frying pan on and then south and west bubbler would start gradually filling, it would get to a point where south and west bubbler are just full. They're stuck full. It's progressed so much beyond that normal dinner bell that Beehive is just ready to erupt and going to erupt. You can sort of think of that as starting a big rocket engine. Beehive, when it starts ringing that dinner bell, it's telling you that, hey, I'm filling up my fuel tanks. I am getting the platform ready. I'm getting everything ready to erupt. But then once you spark that engine, if it's a solid rocket fuel booster, it's just going to keep going and keep going and keep going. So it will get to a point of no return once it's reached significant progression beyond what your normal dinner bell is. Hopefully that answers your question. If not, let me know. So Craig Munson asks, so cold, rain, and night for delaying Indy and Beehive. Any idea why sunset in particular? Is it just that it's sensitive to the temperature change and that sunset alone is enough? As far as I can gather, yes, yes. Temperature, the reason it really doesn't like the nighttime, I think, is because of that temperature impact. The reason it doesn't like sunset is because right as the sun sets, that temperature drops 15 to 20 degrees, and that really makes Beehive upset and angry, and so it doesn't want to erupt for a couple hours after that. The same impact can be observed in the converse during sunrise, where the temperature increases rapidly right as the sun comes up, and Beehive will very much wake up and become alive to that temperature increase. Oh, a good and a difficult to answer question from Ben. Um, Favorite Beehive of the year. So my sarcastic response to that would be every single Beehive, because out of 62 Beehives, there was really only one that I didn't necessarily enjoy. But my favorite Beehive was probably the Beehive that I saw in right before Christmas. I believe it was December 22nd with Mara Reed, because right after the eruption started, amazing. It was 10 p.m. An amazing Beehive shower. It was just two geyser geysers on the hill, and right after that eruption, thanks to the shower washing over all of the ice on the boardwalk, the entire boardwalk became a slip and slide, and we were able to pretty much just slide on our bellies from the plume bench all the way down to the Beehive bench. And that, in combination with just a beautiful 10 p.m., pretty much solo, only one other geyser there, eruption in the winter, definitely takes top Beehive of the year. Just because of all of the circumstances. It was tall, it was loud, it was nighttime. I only had to wait 90 minutes for it. Wasn't too cold, had another amazing geyser there, and also just getting to slide the entire way down the boardwalk in one go it's hilarious. Makes me feel like a child, which I like. Now, yeah, yep, that one for sure. But again, every Beehive this year was very, very, very nice in its own way. So yeah, yeah. But that's a good question, Ben. Here, actually, while I am sharing my screen, I might be able to go find that beehive and show a picture of it really quickly. Do-do. Ah, yes. So it was this beehive on it would have been the 21st of December, right at, oh no, wait. Here, this might take me a second, Ben. That's a very, very good question though, Ben. The 21st of December at 22:16, just because of the amazing beehive luge. So after Beehive started, obviously here you can see us in a getting a Beehive shower, but all of this boardwalk down here that has been completely covered in ice was incredibly slippery, and so we were able to just take a big Beehive luge, big slide all the way down the boardwalk, which was absolutely amazing. And then also we got to go to bed at 10 p.m. instead of 2 or 3 in the morning, which is always a very good bonus. Did I miss anyone's questions? Let's see. If there are any more questions, pop them in now, or also feel free to post them on like the Geyser discussion board. Oh, okay. Good question from Delta 4 Heavy 85, which I believe is Caleb. Can I tell the story of my least favorite beehive from this year? Yes. It was in it. I went to the park for a week in October, and the second beehive that I was there, I got there with someone else at, I believe it was midnight, and it did not erupt until 11 a.m. And it was a very cold night. It started a very big string of bad luck both in Yellowstone and outside of Yellowstone. And so in general, I've sort of ridden that beehive off just because it was a horrible wait. It did not enjoy it. It was the one beehive where, even though I enjoyed it erupting and I enjoyed the wait, looking back on it, I wish I did not try and go out for that beehive. But that is the one exception out of 62 beehives, which is I will take those odds any day. It is definitely better than grand odds. Yes, yes. Grand sits are a living nightmare sometimes.
Also, thank you, Corbin, and we will be back next week with Micah Kipple presenting about geyser paleontology, center morphologies, and its application to dormant/extinct features. It will be on Tuesday here at 7 p.m. on Mountain Daylight Time. Remember that this weekend is our time change, so it will be Mountain Time. Thank you, and have a good evening.